Hello, I'm going to show you how the graph of y equals cosecant of x is done without plugging in very many numbers. I had an email that Mr. Sholari, this is going to take me forever to do y equals cosecant of x without the calculator. And so not really. If you do it the way that is shown in your textbook, um, what is it that we know about y equals cosecant of x? We know that y equals cosecant of x is the same as y equals 1 over sine of x. Okay, so first I'm going to go ahead and graph sine of x. I know that sine of 0 is 0, sine of pi over 2. And let me put my tick mark here. This is 1 right here, and this dotted line is uh, -1. I know sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is back to 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is I'm back to 0. Sine of negative pi over 2, negative pi over 2 sine is -1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is 1. And sine of 2 pi and back to 0. So the graph of sine, which you probably have seen it many, many times, is looking something like this. Okay. And finally, okay. And what is it that I know about cosecant, which is 1 over sine of x? I know that every time sine of x is 0, cosecant of x is undefined. So I have a vertical asymptote at pi because sine of x is 0 at pi. And 2 pi every multiple of pi. And so, I know graph of sine oscillates between -1 and 1. So the graph of cosecant of x is simply a curve that is going like this. And this is going like that. And this is going like this. So you really don't have to do a ton of work for graph of cosecant of x. So what if you have something like y equals secant of x plus 1. Okay, so first you graph y equals sine of x plus 1 and do pretty much what I showed you in here. Show the amplitude, how far up it goes, how far down it goes. Show your vertical asymptote and put your curves just like what I'm showing you here. And that'll be the graph of whatever cosecant of x that you're going to have. Same thing with the graph of y equals secant of x. First, you graph y equals cosine of x. And you know cosine of x is between -1 and +1. Determine where are all the vertical asymptotes, and then put the curves on the tops and and these humps. I guess that would be the right word to use, humps right here, in here, in here, in here, and in here. I think we can do graph of y equals secant of x very quickly. Y equals to secant of x, which is the same as y equals to 1 over cosine of x. Okay, same thing again. And let's give it a, say, 1 and -1. Graph of cosine oscillates between +1 and -1. And so let's say if this is 1, just take marks for okay. Pi over 2, pi, 3 pi over 2, 2 pi, -pi over 2, -pi, -3 pi over 2, and -2 pi. That's good enough. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi, I'm back to 1. And cosine of -pi over 2 is 0. Cosine of -pi is -1. Back to 0 and to 1. And so this is going to look like this. Oh, what did I do? Okay, this is good enough. Cosine of 0, of course, this is my x, this is my y, this is 1, this line is -1. And let me draw my asymptotes. Cosine is 0 at pi over 2. And every multiple of that by the way, there are not sure what page, but these graphs that I'm doing it for you are actually really nicely done on your textbook. Okay, so now all I have to do is draw my humps in here. they do touch in one point. So once again, the key to graph cosecant and secant is first to graph sine and cosine, and then consider 1 over that. That's good enough. Well, I hope you found or you find this video helpful, and thanks.